before we get into advanced load balancer, let's look at the generic load balancers that NSX-T provides actually, and then we'll look into this post lunch. But when we talk about load balancers in NSX-T, remember these are the generic load balancers that NSX-T provides you. I'm talking about that. So there are, you can say, different modes in which you can deploy these load balancers. So we can deploy them in a one-arm configuration or in an inline configuration. The only crucial difference would be if you want the NSX load balancer to work in a one arm, this has a one interface limit on the load balancer. That means your load balancer cannot have more than one interface if you want to have it work in a one arm mode. If you say inline, no such thing. So you can say multiple interfaces can exist. But before getting into specifics, generally when you talk about load balancers, you have some basic configurations to look into. Like normally we create, when you are setting up a load balancer, you normally create something called as virtual service, which is essentially a combination of an IP plus port that you're listening for your application traffic on. So we create a virtual service, like whenever we have to provide host a new application, you will set up a virtual service for that, basically set up a virtual IP plus a port on which you will be listening for that application traffic. Same thing is what you do here also. Leaving that, you have to create a bunch of profiles. So in NSX-T, again, we have this thing called as an app profile, which is like, you can say if it's a layer 4 load balancer or layer 7 load balancer that you're setting, according to that, you will have app profiles telling you how to basically process that particular traffic. So if it's a L4, typically you're going to have TCP, UDP profiles. If it's an L7, you're going to have HTTP or HTTPS profiles actually. So there are a lot of default profiles built in NSX-T for this. You can either use those or you can create your custom profiles for this purpose actually. And then we also create pools, or you can call it as server pools actually, which are essentially a bunch of VMs or containers running that common application of yours that needs to be load balanced. So at the pool level, again, we define, you can say, load balancing algorithms that we wish to use for that particular pool. So you will define some load balancing algorithm like round robin, least connection, least load, and source IP hash, and XYZ. There are so many available. So you can define that algorithm at the pool level on the basis of which load needs to be distributed. At the same time, you also have to, it's not mandatory, but depending upon your application's necessity, you may also have to configure session persistence. Basically, you have to create a persistence profile. Now, persistence technically is not a load balance necessity. It's an application necessity actually. Because if you have an application which says, hey, I need stateful behavior, I can't be working with you jumping clients connections across multiple servers every now and then. So it is basically expecting the load balancer to remember which client connection was mapped to which backend server. Now to remember that, the load balancer would need to maintain a persistence table actually. And that can be based on source IP, based on the HTTP cookie that the load balancer or the application has placed in the client PC. So you can set it accordingly. Giving that, you can also, you would have to also configure health monitors actually. Now, a health monitor essentially is a oversight mechanism by a load balancer. Monitors technically, they simulate client connections towards your backend servers to see whether the server is actually responding or not. So you can set up a monitor saying, okay, my load balancer would basically make an HTTP GET request, or it can basically do an ICMP request towards the backend server to see whether it is actually even alive or not. And depending upon the response got, the load balancer can say that, okay, the server seems to be responding to my monitor calls. So they seem to be healthy. So now I can keep using them. But if a server does not respond beyond a certain extent, the load balancer can say that, okay, this guy seems to be dead. So I would not be basically taking him into consideration and excluding him from my load balancing algorithm completely, unless he starts responding back. So it's basically a you can say a oversight mechanism, which also ensures redundant, you can say availability for your application. That's why there are two crucial benefits why people use load balancers. It's not just to load distribute. That is obviously there, but then load balancers also ensure you have your applications highly available, because they ensure that if a server in the pool is not up, they ensure that the application still gets served from the other servers in the pool actually. So they're kind of increasing the high availability for your applications. So all the same old logics is what you also configure here. Some additional things come additional, like if you say we are using HTTPS and all that, fine. Then you may have to configure SSL profiles also according to the SSL processing you expect. Like if you say I want SSL pass through or SSL offloading, according to that, you would have to configure a client-side SSL profile or a server-side SSL profile. Depends upon that. So the same old specifics, you do it here also, nothing different. So let's look at a scenario where we are talking about one ARM load balancer actually, right? So this is NSX-T one ARM load balancer. So let's say we have two networks to start with. Assume this is network 1 or segment 1. And this is segment 2. So these are the two segments. Let's say a tenant has, and the tenant has his own T1 gateway. So this is the T1 gateway of the tenant. Fundamentally, that is the T1 gateway DR actually of the tenant. So that is connecting to this tenant segments. And let's assume this is the configuration for that. So now the tenant has some machines connected. So let's say he has some web servers connected here. And he has some application servers here. All right, so those are the VMs connected to those segments. And this T1 is talking to this upstream T0. And this T0 is talking to this upstream physical router. Yeah. So between these guys, they have a VLAN network. So assume this is some VLAN 10 or something. So this is the uplink on my T0. And between T1 and T0, we have the router link connectivity. This will again have some VNI of its own. Let's say maybe 5002 or something. And that's the router link configuration done by NSX. So in all of this, let's say there is a tenant, there is a client which is sitting here. So assume that this is some VLAN 20. So there is a client here. And that client is having, let's assume, this address. So now the goal is tenant A, let's say this tenant comes to you and he says, hey, I want to load balance my web servers. And you are looking at an option of one-arm load balancer actually, right? So you want to offer a one-arm load balancer to this tenant. So in order to do that, where would you put the one-arm load balancer? In this topology, where will that sit?
So it would connect to T0.
Mm-hmm.
Right? One connection, you know, it will attach with T0 and then workloads. Mm-hmm.
How would you connect it to T0 then? Because it only has one interface. So if you connect it to T0, how would it reach servers?
So servers, it will reach servers through default gateway, through the routing, automatic routing, auto plumbing is there, right? Between T0 and the T1.
See, in one arm, normally we do that when you are basically trying to put the load balancer and the servers on the same segment. not through routing. So if you put that one arm load balancer here, and first of all, we don't support load balancers on T0, so you can't do that, first of all.
But I can connect T1, right, with T0.
True, but where will the load balancer be in all of this?
So just draw one line with to T0.
To T0.
Yeah. Draw one line, yeah. And one circle, and inside that T1 LB.
So in this case, basically, you're connecting the one-arm load balancer on a different subnet, and then you're routing the traffic to it.
Yeah.
So that is not the ideal way, because you're reaching backend servers through L3 then.
The problem is, if I put it, it will be more of a one in line. Let's suppose you have T1 gateway, and it is acting as a LB also as also connecting the workloads. So even the the traffic which is not required, LV will go through the same T1. That kind of scenario will be there. So we want to avoid that scenario. Only the load balancer traffic should go through load balancer. Rest of the traffic should not go through the load balancer.
True, that happens in inline, not in one arm, no.
Okay, I'm trying to understand from you then.
See, then if that is the case, what is this for then actually, right? We are saying, if you want to put one arm load balancer, can't you simply just put it here? So if I just deploy another T1 and connect that T1 directly,
But one segment cannot be connected with two T1. That's the problem.
Who's it? This is a service interface. You can do that.
It's a service interface.
Yeah, okay. You deploy an additional T1 and configure a service interface to that. You're not using this guy as a default gateway for this network. This is just going to act like a client.
Okay, service. Okay, that's service VLAN you are going to use.
So it's a service interface that you're configuring actually.
Okay. And one more thing, can I do this thing? In my case, T1 gateway is not there. My T1 gateway will be T0 gateway. The 10.1 there is a line.
Okay.
That will line go directly to this segment will directly connect to T0 on the other side rather than T1. In your case, it's a T1.
Okay.
In my case, it will be T1, T0. Could you draw that? Is it possible?
Connectivity was possible. So if you say that if this is not there at all, assume if this is not there, and you're connecting something like this, possible, yes. But you can't be providing a load balancer here. That will still be some T1 behind that.
Yeah, that's exactly my scenario. The circle which is blank is actually T1 and B.
That is possible, yeah. And that will be mostly a single tier topology actually.
Okay. All right.
So in this case, you will deploy a additional T1 gateway. So let's say I'm naming it like a LB, let's call it as tenant A T1 LB or something. Name it whatever you want actually. So on this T1 is where you will now configure the load balancer actually. And remember, when you're setting up a load balancers also come with predefined sizes. Small, medium, large, extra large. There are predefined sizes that you have to choose actually. So it all depends upon what is the size of your edge transport node. And this is especially relevant if you have deployed a virtual edge transport node, a VM. So in lab number 6, you would have noticed when you deployed edge transport node virtual machines, there were some predefined sizes, small, medium, large, extra large. So if your edge itself is undersized, that means if you deployed your edge in a small form factor, you can't expect to set up a large size load balancer on that. Then it will impact scalability like that actually. So make sure you don't, you configure your edge nodes appropriately, because otherwise this will impact the scalability of services that you later on wish to configure. So assuming, let's say my edge is at least configured in large or medium size, I'm setting up a large size load balancer. So
T0, T1 can stay on the same cluster, right?
Yeah, correct. They can.
Okay.
So here, let's say I'm enabling a load balancer service, let's say of some size, maybe like a large or medium or whatever size that suits you. And in this load balancer is where you will now set up your virtual service for my web application. So let's say I'm setting up the virtual service. I'm just mentioning that here. There's no space, that's fine. So here I'm creating a virtual service. And I'm calling that virtual service as web virtual service. And since my load balancer is connected directly to the same segment as my servers are, you'll give it some IP, maybe some 10.1, 10.13. You can either use this interface IP as a virtual service IP, or you can use a different IP also, but in the same subnet. So let's say, for example, if I'm using the same interface IP. So this becomes my VIP. Plus, I give some port for my application traffic. Let's say if it's a web service, that port, 80 port, let's say. So that constitutes my virtual service. And then this virtual service, you have to associate your app profiles, all that. So make sure you have created those profiles and associated those to the virtual service. But then you also have to associate a pool, a server pool. Because who will this virtual service be sending or load balancing traffic on? So you have to create a pool about it. So let's assume I configure these two web servers in a web pool. And this is where you define your load balancing algorithms also. For example, I'm just putting round robin as an algorithm. And then you define your virtual service. So I define this web virtual service actually. Let's say I just mentioned that here. As a result, the VIP for this application is that. So now in one-arm load balancers, ideally you don't really have to do any special advertisements actually. What I mean by that, in the T1 lab also, you might have noticed on T1 gateways, we have this thing called as route advertisements. So as long as you're advertising connected segments already, this VIP IP will already be advertised along with that actually. So there's nothing special you have to do that. But if you configure an inline, then you have to do it additionally. Because in inline, the virtual IP can be in a different subnet also. So here, considering route advertisements are done from T1 to T0, and T0, let's say, is redistributing T1 subnets. Upstream. As a result, this web would be reachable to your physical world. So now this client, let's assume, wants to access this web application. So he initiates a connection. Now, if you look at that packet that comes from his machine, let's assume this is that packet. And in that, we got a source IP as himself, as 192.168.20.100. Destination IP is the virtual service IP, or you can say the load balancer IP. That is 10.1, 10.13. So in this condition, let's say a packet comes from this client PC. It hits his default gateway, which is the physical router. The physical router is anyway getting the routes pushed by T0. So it will simply check its routing table and route the packet to T0. Let's say T0 is going to route the packet to T1 because T1 is advertising those routes to him. So it's going to route the packet to T1. For T1, this is a directly connected subnet, so he knows how to reach. So he simply routes the packet to the destination, which is in this case is the load balancer. So now, what kind of a NAT do you think the load balancer must do before it sends that packet to any one of these web servers? Should it do a source NAT? Should it do a destination NAT? Should it do both of them?
Technically, it prefers both source and destination.
Right, because see, destination NAT anyways you require in any load balancer in this world. That is unavoidable. Source NAT is optional sometimes, but here in one-arm deployments, source NAT becomes mandatory also. Why? Because remember, these web servers are still pointing towards this T1 as their gateway. The load balancer is not their gateway. So to attract the return traffic back to the same load balancer, source NAT is essential. So in one-arm deployments, source NAT also happens. DNAT anyway happens every time. But when we say source NAT, the load balancer will make itself as a source. So it's going to make itself as a source. And then based on the algorithm, it will pick one of these web servers. Let's assume if it picked web 1, it's going to make web 1 as a destination. So now the packet gets NATed from the LB and then it is sent to the server. So when the server gets the packet, will he be able to see the original client IP?
As a default, no.
By default, no, right?
No.
And in most cases, that's not a problem unless your application needs awareness of that actually. So it's more or less an application requirement actually. If your application says
only for audit purpose kind of a thing.
True, right? So it mostly you can say a requirement, and if that is there, what do you think we can do to bring that client IP awareness?
XFF maybe if it is available.
All right. So one is you can enable X forwarded on your load balancer, but considering if it's an L7 load balancer, because you can't do all that for L4.
Okay.
Right. So if it's maybe like an HTTP load balancer, fine, you can enable X forwarded for headers to be added, and the same thing NSX load balancer will do. But X forwarded for, if you say, see from a overhead standpoint, yes, it's an overhead on ILB. Because you're telling a load balancer that, okay, on every packet, you add an additional special HTTP header and preserve the client IP in that, and then forward that to the backend server for information. Now, if you say we don't want to do X forwarded, then the other way is if you just want to have client IP awareness, right? And maybe if you don't have any stringent requirements that, oh, we need to have that on the server level, on the server side, we need to have client IP awareness. We just need to know who connected to us. You can also do that by checking load balancer logs actually, right? So you can check your LB logs also.
But history it will provide much time.
Hmm?
Only the current one we can identify, but not for the history.
True. So that's what I'm saying. If that is a compulsion that you need historical, then obviously you have to enable X forwarded, or you have to set up that application in an inline load balancer approach then actually, right? If that's a compulsion. But if you just want to know actually who just connected to us, if that's just a requirement, that's not going to impact you so badly. Maybe you can also check that through LB logs also actually, right? So depending upon your application requirement or compulsions, these things can be done. But ideally, in a one-arm load balancer, This is like a full proxy kind of a load balancer, you can say. So it's not going to let the backend servers know who is the client by default unless you tell it to do X forwarded for or something similar like that actually.
Shekhar, one question I have regarding the routing. The T1 LB, and how did you know the client IPs? There is no auto plumbing, right, between T1 and T1.
This T1 you're saying?
Yeah, return traffic towards client, because the return traffic destination will be original client IP.
True. So anyway, he's the one who's natting it, right? So he'll be tracking those connections anyway. So he will know what is the client actually.
Yeah, there should be routing also, right?
So for routing, anyway, we have to see for one arm you have to anyway put a default route actually.
Yeah, default route pointing to T1 gateway route. Yeah.
True. So that anyway is there. So that with this.
Yeah. Thanks. Right. The service service VLAN is basically is key. We try to do it the same thing, but with a normal interface. And we could not connect the segment with.
This is not a service VLAN. This is a service interface.
Service interface, yeah. Service interface, correct. Agile 3 interface, right?
Okay. So this service interfaces you can connect to overlay also.
Now we can think of it also. We remove that from the architecture because of lack of knowledge on this NSX-T. Yeah, thanks for this. Yeah.
All right. Now imagine in the same situation. If this tenant comes and he says, hey, I want to load balance my application servers also. These two. So can I use the same load balancer for that?
Yeah, we can get one more interface, right?
But this is one arm, man. One interface is the limit.
It is very difficult, with a lot of routing and all that stuff. Maybe it's a workaround.
Right. So ideally, if you go by the default nature of it, you can't, because one interface is the limit. Yeah. That means you would have to put one more one more T1 here on the app segment and configure it for that actually.
Yeah, that's kind of limitation.
Right. Yeah. Unless you don't want to reach everybody through L3 hops and all that, right?
Yeah. In our case, we have multiple segments, right? And in some cases where there is just one segment and hundreds of VMs are hanging off of it, then one arm load balancer is useful. If you have multiple segments and the pool members are sitting on multiple segments, then you cannot afford to have those many LVs, right?
True. So that's what, if you adopt the new DFW micro-segmented approach of deploying your applications on a standard segment, you can actually use the same one-arm load balancer for your complete application also.
Yeah, for that you're right. Anyway, DMG concept, but for that something similar should have been designed. We are migrating from NSX to T. We may have multiple segments. So most of the people are creating multiple segments.
True. That's what I'm saying. See, because we are still in a transitioning phase. Even today, most people don't even think of putting everything on the same subnet, even though they know that NSX has been there from last 10 years now, actually. DF distributed firewall is there from such a long time. It can actually help them achieve the same things. Even for newer deployments, we still go with legacy approaches. It's a mindset problem, again.
Yeah, agree.
Right. So unless we adopt this methodology completely, then I would say inline would be your best option till then, actually. So
yeah, Shekhar, that's like only the one arm and inline LB. It's only like a definition, right? Like how we configure. Even for the existing LB, we can attach only the configuration based. We define some one arm. That's it, right? There's
there's no special type or one arm or something. No, it's just the configuration.
Yeah, that's it. Yeah.
All right. So, what if in this scenario, if I say I don't want to do one arm, I want to do inline. So where will your load balancer sit in that case?
No, in that case, directly instead of connecting it to the 10.1 segment, directly we'll connect it to T1 gateway.
All right. So the only differences you will notice is going to be that this thing is going to be right here, and that is going to be there.
No, we can connect directly here one. Kind of this one, right? We have one VSI connecting to the 10.1.10/24 subnet, right?
Okay.
That link will connect to the esxi, like just now. I think I forgot I didn't say his name. He was telling right, we are connecting to T1 to T1 connectivity.
Mm.
We can provide, we can use this only for the LB purpose. We can use this, and another for other traffic we can use this gateway.
But he was trying to connect it to a T0.
No,
basically.
the similar way we can connect it to T1 gateway itself, right? So all the, like, even it will be more secure, right? So all that internet traffic will not land into the server segment, server VLAN, or
No, possible. You can do it that way. It's not like that. This is only approach.
Yeah.
You can do it that way also. It says that with inline, you can either, if you wish to leverage your existing T1, you can, or you can create a separate T1 and you can configure it in a way that only your application's LB traffic will use LB, and any other traffic is going to bypass the load balancer and use the traditional T1 actually.
Yeah.
Right. Possible.
Check
So
out.
you can do it that way also. Yes.
Service interface, right? So VLAN is not required to configure it, right?
No.
Okay. And one more question on this. Can we attach like secondary subnets to the service VLAN? Service interface, secondary subnets, IP from secondary subnets.
No, it doesn't. I haven't seen an option, but I don't think so. Yeah.
Yeah, we have a scenario where we need to extend things for different subnets. Okay.
Right.
Okay. Yeah.
But
We'll
as
see.
of now, I don't think we can.
Okay. Thanks.
All right. So these are the two options that you got in native load balancer of NSX-T actually, and we only support load balancers on T1. If you talk about native load balancers of NSX-T, we only support them on T1 gateways actually. You can't do it on T0s. Right? Even if you say I'm running my T0 in active standby, can't I do it? No, you can't, because it's not supported. So in any case, make sure whether you go with inline or you go with one arm, the load balancer has to be or must be configured on a T1 gateway to function. And another thing to remember, see, when you deploy one arm load balancers, right, specifically, there is no DR created. It's only the SR. Simply because you are creating a service. You're basically trying to create a service. And to have that service run, you need a SR only. So this SR will exist only inside the edge node. It's not going. There's not going to be a DR for that. You can say load balancer T1 gateway actually. Only an SR would be configured. That's applicable for a one-arm deployment. For inline, anyway, you're going to have basically a DR also, most probably. All right. So, any questions, guys, on this native load balancer? Okay. So let's take this as 110, and let's be back by 2 post lunch.
This one we can like on the current existing T1 gateway we cannot, right? It's a load balancing is like in NSX we on the existing edge only we can add the LB this one, right? Similarly on the here existing T1 gateway, can you put that LB this one?
Yes, you can. Yeah, it's possible. You can put it on this T1 itself actually. Yeah. But that will be considered as an inline deployment actually. Right? Not as a one-arm.
No, because I'm in just the parallel in the console, right? I'm just checking when I click on the load balancer, right? Add, it is giving option to add load balancer. So I'm not seeing like where to use the existing one, the T1 as this one, right? Only it is.
You have to associate. So just share your screen once. Okay, 1 second. I'll stop sharing.
Oh, just where it is. Oh. Okay, start video show. Okay, screen. Is it visible?
Okay.
Yeah. Here, I'm seeing load balancing, right? Here, can you associate existing? Because here I have one existing. I have T1s, right? I want to use this T1 as a load balancing.
Yes,
So
you can.
here we have to configure, or we have to come back to load
See,
balancer?
the problem is because your see, if you notice, this T1 does not have an SR. That's why it's not showing there actually. See, edge cluster is not set. It says.
Oh, okay. Yeah.
That's why.
Okay.
So just say, make sure that there is an SR for this, and then you can associate.
Oh, then it will show the in the drop down.
Do it. No, do it. That's okay. Do it. Edit this T1 and choose that edge cluster in the drop down. Okay, save it. Go back to LB.
I should get a drop down, right? What the name?
Not there. You have to give a name for that. That is the LB name. Type whatever, some jargon there. That's okay. All right. Now in the attachment field, in the drop down, there you have it. See, T1 gateway 01. It's giving you, no?
No, it's attachment only, connectivity to that one, right? Not that only acting as this one, right?
That is acting. Attachment means you're configuring the load balancer on that gateway.
No, okay, just a moment. Because
otherwise, see, tell me, is load balancer a separate entity in NSX-T? No, it's a service on a gateway.